Space tourism is selling you the dream and quietly hiding the ways it can kill you. The radiation alone at orbital altitudes would expose your body to an invisible environment that no sunscreen, no atmosphere, and no Earth-based intuition prepares you for. And radiation is just the first danger on a list that nobody in the brochure wants to assemble into one honest picture. But radiation is not even the danger that worries aerospace physicians the most. The one that keeps them watching closely is something your body has been depending on for your entire life, and you have never once had to think about it. Gravity. Not just the absence of it, the transition. Here on Earth, your cardiovascular system is a finely tuned machine built around a single assumption. Blood must be constantly managed under a 9.8 meters per second squared pull. Your heart pumps blood upward to your brain. Your leg veins use one-way valves to help push fluid back toward your chest. Your muscles squeeze your blood vessels every time you move. Your entire circulatory system is built for a planet that never stops pulling down. Every second of every day, your body is fighting gravity without asking your permission. Then orbit removes the rulebook. The moment you enter microgravity, your body does not celebrate. It starts adapting, fast, and not always in ways that help you. Within hours, fluid begins shifting from your lower body into your chest, neck, and head. Your face can puff. Your nasal passages can swell. Your legs can become thinner. The body reads this headward fluid shift as if it may be carrying too much volume, so it starts adjusting. You urinate more. Your blood volume begins to change. Your cardiovascular system starts adapting to an environment where it no longer has to fight gravity in the same way. On long-duration missions, astronauts can return with measurable cardiovascular changes, including changes in heart size, blood pressure control, and tolerance to standing upright again on Earth. Now think about what that means for a space tourist. Professional astronauts spend years preparing for this environment. They train for launch stress. They train for re-entry. They train for emergencies. Their bodies are tested, monitored, measured, and compared against medical baselines before and after flight. They are not just passengers. They are trained biological operators inside an extreme environment. A tourist on a commercial orbital flight may have medical screening, ground support, and safety procedures, but they do not have the same years of conditioning, operational training, and career-long medical monitoring built around professional astronauts. They may have passed the screening. They may have signed the waiver. They may have watched the safety briefing, and then they are floating hundreds of kilometers above Earth, smiling at the window, while their cardiovascular system begins rewriting itself for a world where down no longer exists. The timeline matters here. Even a short orbital stay of 2 or 3 days is long enough for fluid shifts and early cardiovascular adaptation to begin. Re-entry does not reset the clock. It introduces a new stress. As the spacecraft decelerates and gravity returns, blood is pulled back toward the lower body. For a conditioned astronaut, that is a known and managed challenge. For a civilian passenger whose body has already started adapting to weightlessness, it can mean dizziness, weakness, nausea, disorientation, or sudden drops in blood pressure at exactly the wrong time. Not necessarily disaster, but risk. And in space, risk does not need to be dramatic to become dangerous. The brochure calls it a once-in-a-lifetime experience. The physiology calls it a cardiovascular stress test with no warm-up, no normal horizon, and no planet underneath you until the fall back home begins. And here is the thing. The cardiovascular threat does not operate in isolation. It has a partner, one that tourist brochures are even less likely to explain clearly, because it does not announce itself with symptoms you would recognize. It does not make your face puff in a way you immediately understand. It does not make your legs feel weak. It works quietly, invisibly, behind your eyes. That partner is pressure. Specifically, the pressure environment around your brain, your eyes, and the fluid systems inside your skull. When fluid shifts upward into your chest and head, that movement does not stop at your cheeks or sinuses. The fluid dynamics around the brain and eyes begin to change too. On Earth, gravity helps regulate how fluids move through the body. Remove gravity, and the passive drainage systems your body depends on begin operating under unfamiliar conditions. Aerospace physicians have a clinical name for one of the most serious long-duration outcomes linked to this environment: spaceflight-associated neuroocular syndrome. SANS. It has been observed in astronauts after extended missions in microgravity, especially aboard the International Space Station. And what it revealed was deeply unsettling. Some astronauts returned with measurable changes to their eyes, swelling around the optic nerve, flattening at the back of the eyeball, changes in vision, shifts toward farsightedness. In some cases, these changes did not fully reverse after return to Earth. Their bodies had spent so long in microgravity that the structures behind their eyes physically changed. Now bring that back to the tourist on a short commercial orbital flight. A 2 to 3 day flight is unlikely to produce the full syndrome seen in long-duration astronauts. But the same environment begins immediately. The same headward fluid shift starts early. The same pressure dynamics around the eyes and brain begin changing. And the passenger may have no pre-flight eye imaging, no neurological baseline, no long-term medical follow-up, and no personal experience that would help them recognize what is normal and what is not. Imagine floating near the observation window, watching Earth scroll beneath you. While somewhere behind your eyes, fluid pressure is shifting in a way your body has never experienced before. You feel wonder. You feel weightless. You feel lucky. But inside your skull, the old rules have changed. That is not a fantasy risk. Researchers studying SANS have described it as one of the major unresolved medical challenges in human spaceflight. For a tourist, the danger is not that a weekend in orbit will automatically damage their vision forever. The danger is that space begins changing systems most passengers do not even know exist. And unless someone is actively looking for those changes, the body may stay silent until after the flight is over. Knowing that even a short orbital flight can begin shifting pressure dynamics behind your eyes, would you still buy a ticket if the brochure explained that risk up front? Drop your answer in the comments below. Because what waits beyond the skull operates on an entirely different timescale. Pressure and fluid shifts are not the only invisible forces working on your body from the inside. There is a third threat woven into the orbital environment, one that does not build gradually over hours the way fluid shifts do. This one begins the moment your spacecraft climbs above most of Earth's protective atmosphere. And it does not stop for the entire duration of your flight. Radiation. The problem is not just that space radiation exists. The problem is that your body has absolutely no way to tell you it is happening. On Earth, you live under a layered shield. The atmosphere absorbs and scatters much of the radiation coming from the sun and deep space. Earth's magnetic field helps deflect charged particles before they can reach the surface. That protection is so constant that human biology never evolved a warning system for high-energy radiation. No pain receptor fires, no nerve-ending triggers an alarm. There is no burning sensation, no pressure, no heat, no sound. High-energy particles can pass through the spacecraft, through your seat and through your body while you feel exactly nothing. And at the cellular level, they can break chemical bonds. They can damage DNA. They can trigger repair systems your body normally uses on Earth, but in an environment where the dose, particle type, and exposure pattern are different from anything sea-level biology evolved to handle. Imagine you are floating near the same observation window, Earth below you, black space above you, the cabin quiet. And at that exact moment, charged particles from the sun or cosmic rays from deep space are passing through the vehicle. You see the view. You feel calm, but your cells are experiencing an invisible storm. For professional astronauts, radiation exposure is tracked carefully. Space agencies monitor cumulative dose. They design mission limits. They study long-term cancer risk, central nervous system effects, and tissue damage. Those limits exist because the risk is real. A civilian passenger may not receive the same lifetime radiation tracking, career exposure management, or personalized risk monitoring used for professional astronauts. They are not building a spaceflight career. They are buying one flight. One seat, one window, one chance to look down at Earth. And the radiation dose from a short orbital flight is not instantly catastrophic. But it is real, it is invisible, and it is higher than what your body experiences at sea level. The timing matters too. Solar activity rises and falls on an 11-year cycle. During active periods, the sun can produce powerful eruptions and solar particle events that raise radiation exposure above normal orbital background levels. These events are not always predictable far in advance, and if one happens during a civilian mission, the response depends on the spacecraft, the orbit, the shielding, the warning systems, and the procedures available to the crew. The brochure shows you the view. It does not show you what is passing through the window, and yet, even with radiation saturating the orbital environment, the commercial space industry has a ready answer. Shielding. The spacecraft hull absorbs some of it. Modern materials help. Mission planners monitor space weather, and all of that is true, as far as it goes. But there is another threat that no hull shielding can stop, because this one does not come from outside the vehicle. It comes from inside your own body, specifically from your bones. Your skeleton is not a static structure. It is living tissue. Every day your body breaks bone down and rebuilds it in a process called remodeling. That process is driven by mechanical load, by gravity pressing down on your skeleton and your muscles pulling against it. Your bones are strong because Earth keeps asking them to be strong. Remove that load and the signal changes. The cells that break bone down keep working. The cells that build it back up receive less mechanical reason to maintain the same strength. On long-duration missions, astronauts can lose significant bone density in weight-bearing regions like the hips, pelvis, and lower spine. This is one of the major medical problems of extended spaceflight. Now anchor that to a space tourist. A passenger is not going to lose months of bone density in a 2 to 3 day orbital flight. That would be false. But the biological signal begins changing almost immediately. The skeleton is suddenly in an environment where it no longer has to carry body weight. The muscles are no longer loading the bones in the same way. The remodeling balance starts to shift, not catastrophically, not visibly, not in a way the passenger would feel while floating at the window. But the process has begun, and over longer missions, calcium released from bone can increase kidney stone risk and add another layer of physiological stress. That is the pattern space keeps repeating. The danger is not always immediate destruction. It is adaptation. Your body starts solving the problem of space by becoming less optimized for Earth. Your heart adapts. Your fluids adapt. Your pressure systems adapt. Your bones adapt. And then after days, weeks, or months, gravity returns and demands that every system remember the old world at once. These systems are not separate dangers lined up in a polite queue. They interact. The fluid shift that changes pressure dynamics around the eyes also changes cardiovascular load. The cardiovascular changes affect how well you tolerate re-entry. Radiation adds cellular stress in the background. Bone and muscle unloading begin shifting the body away from the architecture Earth built. And all of it is happening while you are trying to enjoy the view. Imagine floating at the observation window again. Earth curving below you. The silence of orbit surrounding you. Your phone cannot call an ambulance. There is no emergency room behind the cabin wall. There is no instant return to Earth. And every major system in your body is being asked to operate under rules it did not evolve for. That is the picture the brochure rarely assembles. Not because every individual risk is hidden. Some appear in waivers, some appear in medical briefings, some are known and managed by mission planners, but rarely are they placed side by side and shown as one complete physiological environment. The industry sells the view. The body experiences the whole system. And if you are thinking that all of this, the fluid shifts, the pressure changes, the radiation, the bone unloading, sounds like a checklist of risks that a well-designed spacecraft and a competent support team can handle, the commercial space industry would agree with you. That is exactly what they would say. And in many cases, they may be right. But there is one final layer that makes every previous danger harder to manage. Not because of what it does to your body alone, but because of what space does to the only person who might notice something is going wrong. Your mind. The final risk is not that a tourist suddenly becomes unable to think. It is that spaceflight piles stress on the brain at exactly the moment when clear judgment matters most. Microgravity changes the way your body senses orientation. Your inner ear can become confused. Motion sickness can hit hard. Sleep can break down. The schedule is unfamiliar. The cabin is strange. The view is overwhelming. The stakes are enormous. And underneath all of that, your body is dealing with fluid shifts, pressure changes, radiation exposure, launch stress, re-entry stress, and the simple fact that you are in a machine moving through vacuum. Professional astronauts train for years because emergencies in space are not just technical events. They are cognitive events. You must hear the alarm, understand the alarm, remember the procedure, find the correct control, coordinate with the crew, fight panic, and do all of that while your body is already under stress. For a tourist, the challenge is different. They are not expected to pilot the spacecraft. They are not expected to run the mission. Modern commercial vehicles are designed to automate as much as possible. But automation does not erase human vulnerability. If something feels wrong in your body, will you recognize it? If an alarm sounds, will you understand it? If smoke appears, pressure changes, communication fails, or re-entry becomes rough, will your mind stay calm enough to follow instructions? That is not an insult. That is the core reason astronauts train. Because space does not only test machines, it tests the human being inside them. Now imagine yourself one final time at that observation window. Earth is below you. The silence of orbit is around you. The planet looks peaceful from up there. No borders, no noise, no gravity pulling at your feet. For a moment it feels like freedom. But inside your body the old rules are gone. Fluids have moved. Pressure has shifted. Radiation has passed through you. Bones and muscles have begun receiving the wrong signals. Your balance system is confused. Your sleep is broken. Your brain is trying to process the most unnatural environment a human body can enter without dying immediately. And the most dangerous part is that almost none of it feels dramatic while it is happening. There is no monster, no explosion, no visible wound, no warning light inside your skull, just adaptation, quiet, invisible, relentless. That is the danger nobody in the brochure assembles into a single, honest picture. Not one risk in isolation, but the compounding architecture of a human body under orbital stress, guided by a mind that must remain calm inside an environment it was never built to understand. Space tourism is real. The dream is real. The view is real. But so is the cost, because orbit is not a hotel. It is not a cruise. It is not a luxury balcony above Earth. It is a hostile physics experiment wrapped in glass, metal, marketing, and wonder. And when you buy the ticket, you are not just buying a view of the planet. You are volunteering your body to leave the environment that made it possible. Subscribe to Cosmos and hit the bell so you never miss what we uncover next. And if you want to keep going, watch the next video on your screen now, and grab your free guidebook from the description below.